Hello students. Today we're going to look at transformations of linear functions. Okay, so you see the word transformations here. So I'm going to write on the side transformations of linear functions. That's what we're talking about today. Now, transformations is a change of linear functions. Now, all of these changes happen to the parent function, and so I'm going to have you write this at the top of the orange page. The parent function, which is y equals x. Okay, parent function meaning that is the basic function that we have for linear equations, y equals x. And when we graph y equals x, we'll just do a little quick picture of it. It passes through the origin because b is 0 and the slope is 1 over 1, so we go up 1 over 1, up 1 over 1, up 1 over 1, and we can go down 1 to the left, down 1 to the left, down 1 to the left, and that is the actual parent function. That's the line. If I drew the line through those dots, that would be what the parent function looks like. Well, when we transform that parent function, then we're going to be adding to the y equals x. So it might be y equals 2x plus 3. That's a transformation of the parent function. And we're going to look at the 4 different ways to transform a parent function using the letters A, B, C, and D. So we're going to go through this pretty explicitly as we talk about what these functions mean. Okay, so we're going to start with the letter A. What's happening here is I'm multiplying the function by some value which is A. Now if that A is greater than 1, we've got what we call a vertical stretch. And I'll show you what these look like in just a second when we go through. We're just going to write down what the actual transformation is. Now if that letter A is between 0 and 1, which would mean it's a fraction or a decimal, then what we have is a vertical compression. And there's supposed to be 2 S's in compression. Sorry about that. And if that letter A is less than 0, meaning it's a negative number, then we have a vertical reflection. Now again, I'm going to tell you about what all these are as we go through this process. So that's if we change the letter A. So now let's look and see what this is actually going to look like. So we're going to open up the A flap, leave the F flap closed, and here we have a graphical representation of what this looks like. Okay, so when A is greater than 1, we know, I'm just going to, well, A is greater than 1, so that's going to be any number greater than 1. For instance, we could multiply the function by 4. What that means is we said that it was a vertical stretch. That means that the line, this parent function, gets closer to the y-axis. So it could look something like this. It's still going through the origin. Missed it a little bit. But the line, because it's a stretch, is getting closer to the y-axis. And so we would call this description a vertical stretch by a factor of 4. Because we multiplied by 4, we know it's a stretch because that letter A is greater than 1. Okay? So now let's look what happens if A is between 0 and 1. It's a fraction or a decimal in this case. It could also be 1/2 f of x. Then what that is a compression. A compression means it gets closer to the x-axis. So basically what you look like, you're pushing down on that line, and when you push down on the line, it gets closer to the x-axis. So it could look something like this, where my line is closer to the x-axis. Now I know you're supposed to be drawing with rulers, but in this case, because we're not actually connecting points or anything, we're just showing what the line is going to look like. Any type of compression is going to be a line that moves closer to the x-axis. So this would be a vertical compression, and I'll spell compression correctly this time, by a factor of 0.5. Okay? So what happens if the A is less than 0, which makes it a negative number? So in this case, I just have a negative F, so I multiplied by -1. Well, in that case, what that means is it is a reflection across the x-axis. So I'm going to go ahead and write this. Reflection across the x-axis. Okay, that's a vertical reflection because it's reflecting across the x-axis. So what that's going to look like is when I reflect across the x-axis, this part of the line is going to go down here, and this part of the line is going to go up here. So basically we reflected across this x-axis. That's exactly what it is. Anytime it's negative, A is negative, excuse me, anytime A is negative, we reflect across the x-axis. Now we could have -3, which means it would be a stretch and a reflection across the x-axis. So your line would be reflecting, but it's also going to be closer to the y-axis because it's a vertical reflection, a vertical stretch and a reflection. So now let's look what, let's say that A is -3. So I would say -3 f of x, and we know that that is a vertical stretch by a factor of 3, and it is a vertical reflection. Okay? I didn't put vertical reflection up here, but it is. It's a vertical reflection, which is across the x-axis. So, first of all, I'm going to reflect it, and I'm going to make it a stretch, so it's going to go closer to the y-axis. That is a horrible line. Okay? Sorry about that. So we're still going through the origin, because we don't have a plus or a minus or anything over there. We got closer to the x-axis, and we reflected it across, closer to the y-axis, and we reflected across the x-axis. Okay, so again, A is all about what happens to the line, whether it's a vertical stretch, a vertical compression, and then a reflection. I promise when we practice these, it'll make a lot more sense. Okay, so now we are going to look at what happens when we use D. And D is always going to be either added or subtracted from the function. Okay? So, if D is greater than 0, then we're going to translate up. Because D would be positive, and positive, we go up. If D is less than 0, that means D is negative, then that means we're going to translate the entire line down. Okay, this all has to do with what my y-intercept is. Because remember, mx plus b, so we're adding, in this case, I don't know why they didn't use b, but it's using d. So when we change d, if we change d for the positive, it goes up. If we change d for the negative, it goes down. So let's see what that looks like when we open up and look at some examples here. Okay, so if we have f of x plus 4, that means the entire line is going to shift up 4 spaces. So it's still going to be parallel, but it's just going to shift up 4 spaces. Okay? So that's a vertical translation up 4. Well, in this case, we have f of x minus 6.3. So we know that's going to be a translation down. So again, we're still going to stay parallel, but the y-intercept moves down. That might not have been exactly 6.3, but it's just a representation that we're moving down. So this is a vertical translation down 6.3 units. Okay? Now, you try. So here we're mixing A and D. So it's going to be a little bit tricky. We got a lot of stuff to deal with. So I'm going to write it as 1/3 times the quantity or times f of x minus 2. Okay? 1/3 means it's going to be a compression, which means the line is going to be closer to the x-axis, but we're also moving it down too. So it's going to be something that looks like this. Okay? I compressed it, so I got it closer to the x-axis, and then I moved it down 2 spaces. And we call that a vertical compression by a factor of 1/3, and it's also a vertical translation down 2. Here's this other one. We're going to rewrite it as -3/2 f of x plus 8. So let's talk through this one a little. I've got -3/2, but that we know is going to be a reflection, but it's also 3/2. If we just look at that 3/2, forget about the negative, just look at the 3/2, that is a number greater than 1. Even though it's in fraction form, it's still a number greater than 1, so that's going to be a stretch. The line's going to move closer to the y-axis. And then I'm going to move up 8 on the y-axis. Okay? So this is what it's going to look like. Something to the effect of this. First of all, I have a stretch, so I brought the line closer to the y-axis. It's a reflection, so you see how I reflected it across the x-axis, and I had to move it up 8 on the y-axis, so we have a vertical stretch by a factor of 3/2, a vertical reflection across the x-axis, and we have a vertical translation up 8. A lot of stuff. I know it's a lot, and we've only gone through 2 of them. Okay? So, we're going to take it slow, we're going to learn them, and you're going to do well. Now let's flip over to the back. You see on the back, we're just going to write a description of what's going to happen. So I'll do the first one, f of x minus 3, that's going to be a vertical translation, that's an L, down 3. Because the only thing that changes is that minus 3. Now these others have A and perhaps D, so I want you to describe exactly what's happening in each one of those for this part of the video.